3.
Number.
And then we'll go over number 5. But I got, like, when I submitted it and I saw, like, did you guys find an equation to do those problems? Or did you just have to figure it out on your own?
Just kind of had to figure it out. I only got number 1 or letter A right.
I didn't even get any of them. When I like submitted it and saw the key, and then she had these equations laid out, then I figured out how to do it. But
yeah, exactly. I mean, like in the reading, it wasn't very clear as to like
I know, I was so confused.
what equaled what, but then yeah, after I saw that, it made sense.
Mm-hmm. It's still kind of confusing, but at least I know like what numbers you plug in where.
Yeah.
I guess. But yeah. So did you guys have any other questions, or should we just go over number 5 really fast?
I'm
Yeah,
good for move on.
Let's do number 5. That sounds good. Are you guys ready for the test?
No.
Has anybody taken it yet?
Mm-mm. I didn't do too well on the I did good on the written part, but on the multiple choice part, I didn't do very well.
Yeah, it was
It was
hard.
the opposite.
You did well on the multiple?
Yeah, I did good on the multiple choice, but then didn't leave myself enough time to do the written part and didn't do so good.
Oh, yeah, that's right.
Do you guys know, is it just over the past couple lessons, or is it cumulative?
I think it's just over 5, 6, and 7.
Okay, that's good.
Yeah, I don't think any of them are. I think she even said like the very last exam isn't a cumulative.
Okay.
Yeah.
Cool.
Okay. So number 5. Okay, so describe what is meant by the 5' on the left-hand side of the molecule.
Okay.
So, I remember from watching the videos, 5' means, I know it goes from, does it go from 3' to 5' or 5' to 3'?
Depends on what side of the molecule you're looking at.
Mm-hmm.
Yeah, it always goes opposite.
They're anti-parallel.
Yeah, exactly.
Mm-hmm.
So 5', there is something, oh, I need to look at a picture, but it's like something spacing up on the 5'. And I think it's like on the 5' end, it's like, I don't know, like the phosphate group is facing up or the something is facing up, and then
yeah, there's a phosphate group attached to the 5'.
Yeah.
And then I think on the 3' it's like the hydroxyl group is facing down or something.
Yeah.
And then also you can't add anything to 5', you can only add to 3', right?
Yeah.
Or is that not right?
That sounds familiar.
Have you guys taken Bio 181?
Yeah.
Okay, I didn't know that was a prerequisite. Because yeah, I remember learning about like with transcription and translation and stuff, and one of the ends, it has like a tail is at the 3' end, and then that's where the other
Yeah, I think so.
It's like a zipper kind of.
Yeah. I think that sounds right, yeah. So yeah, I think when it says describe what is meant by 5' and 3', it's just like indicators of what? I don't know.
Yeah, just like what, like how you know that it's 5', like what makes it different from 3'.
Yeah, so I think the difference is the presence of a phosphate group for the 5' and then the hydroxyl group for the 3'.
Yeah. That sounds good to me.
Yeah, me too.
Yeah, I don't know if there's any other main differences besides that we need to know.
I'm Googling it really fast.
Okay.
Identify them.
Letter C is easy.
Yeah.
Yeah, so it says, So one end of each chain carries a free phosphate group attached to the 5' carbon. This is called the 5' end. The other end has a free hydroxyl group at the 3' carbon, and this is called the 3' end.
Okay.
Which we already stated, but okay.
Perfect.
So did you guys have any questions about C?
Let me see. No, yeah, that's really easy.
Okay.
Suppose my customers.
Yep, just pair A with T and C with G and switch the 3 and the 5 sides.
D, I kind of don't really know how to do that.
Okay. Well, so what I did is I counted how many were in the link, the chain. And so that's how she got the 25 base pairs. And then in the reading, it just said since there are 10 per every, I don't remember what it was called, like a cycle or a turn, is that right?
Yeah, turn.
Yeah, so 10 per every turn, and since there's 25 base pairs, then you just divide it.
Right, so you get 2.5 turns.
Yeah.
Really? So you divide, and like in order to find how many turns there are, you divide however many base pairs there are by 10?
Yeah.
Yeah.
Really? Okay. That makes it easier.
It's a lot simpler math than those equations on number 3.
Yeah, those are dumb. Have you guys started tomorrow's homework at all?
No.
Oh.
I wish we
Never
didn't
mind
have
then.
homework because we have an exam.
I know, I wish they would take, and like we have homework and then we also have a quiz and then we have a test. I had a question on next week's, which I think is kind of the same. Let me see. Around this. Oh, never mind. It's asking, like one of the like, do you guys know how to find like how many radial loops are on like a chromosome?
How many radial loops?
Is that from this week?
Yeah, that's the assignment this weekend. But but you guys haven't started yet. But I just didn't know if there was like an easy answer to that. If you don't, then it's not a problem.
Going to the reading right now, see if I can find it there. And you said radial loops?
Yeah.
Radial.
It's like down near the end of
Okay.
the reading.
By the 300 nanometer fibers. What does the question say on?
It says. Crap, where did it go? It says. So you have two pieces of chromosome 14 and 21, and they there's a fusion between them. So when, geez. So there's a total of 157 million base pairs.
Okay.
And so it's just asking how many radial loops would you expect to find within this translocation chromosome?
So it says here that each loop consists of 25,000 to 100,000 base pairs of DNA.
Yeah, and that's such like a wide range, like 25 to 200,000.
I guess you just like pick a number in between and then
Yeah, what I would do is put
Right.
anywhere between this many loops and this many loops. So divide them by,
Oh, so do like 25,000 and then divide it by 200,000.
so anywhere between X
Okay,
number of loops and Y number of loops.
That makes sense.
that's a good way to do it.
Good thinking, Jackson.
Good job. I like these group chats. Yeah, how long are we at now? Are we at 30 minutes yet?
No, it doesn't tell me how long I've been live.
I think it's been like 20-ish, maybe.
She said it's supposed to last at least 30 minutes.
Huh. Well, I feel like this week, like it wasn't a lot of problems you had to do. It was just kind of like fill in the blank or like define what it is.
Yeah,
So
besides, yeah, except for like number 3.
yeah,
I mean, we could go over like the steps and number, because I guess I don't really understand like what the, like I just plug numbers in and I guess I don't really understand why I was plugging numbers in. Just following her equation.
yeah, it didn't really make sense in the reading to me. So once I saw that, then I'll probably just like try and memorize the equation and then just plug it in on the test.
Yeah. Well, okay, so like on 3, why did like on like 3b, why does it say, so you have like 1.97 times 10 to the 8th base pairs, and then why does it have one nucleosome over 196 or 197? Is that because, or like,
I think it's kind of the same thing like with the radial loop. Like it could be 196 or 197. So
it's not just because there's 197 million base pairs? Or is like one nucleosome every 1 million base pairs? Or
yeah, I don't know. But I mean, she gave 2 answers, so it could be either one. Yeah, because on C and D it says the one nucleosome is the same thing as the 196 or 197 base pairs.
yeah. In the equation it says that, or did you say that in the reading?
On the equation it says that, so I'm
Yeah.
guessing that's probably what one nucleosome equals.
Okay, I didn't know if it was like, okay. Oh, frick, I'm gonna have to go back and redo some then.
Yeah.
One nucleosome is around 196 or 197 base pairs. So what do we need to know the average length of the linker? That's where I'm getting confused. Why do we need to know the DNA is 50 base pairs for the linker length?
That's
Oh, yeah. I was wondering about that too.
well, maybe, okay. So this thing says a nucleosome core particle consists of 146 to 147 base pairs. So maybe they're adding an extra 50 to get 196?
Oh. That makes sense.
Does that?
So they're saying the average is 146.
Yeah,
And
146 to 147.
Okay, and then ours is 50 base pairs longer than the average. Is that what that's saying?
Average length of the linker. What's a linker?
I don't know.
Or the linker is adding an additional 50 base pairs to the.
Oh, okay. Each nucleosome is connected by a linker region of between 20 to 100 base pairs. Histone 1, also called the linker histone, interacts with the linker region DNA.
Okay, so you got the 2 strands, and then the linker connects the 2 of them together, and the linker is 50 base pairs long.
Yeah.
Two together to get the total length.
That makes sense now.
Yeah, so each nucleosome is connected by a linker region. So, okay, so I was just thinking, like when I was thinking, okay, 197 million base pairs, so that means that 197 base pairs. I don't know why I was thinking that, but.
Yeah, well, because it doesn't really explain that in the reading, or at least I didn't understand that.
Yeah, no, me neither.
No, I didn't catch that either.
I was hoping to find like an equation somewhere or something.
Yeah.
I was all over Google trying to find this stuff, and
I know, me too. And like there's like a problem in this weekend's assignment and it says like you have to do a little bit of your own outside research and I could not find it. And so I just made up answers
Yeah.
because it talked about
oh great, I don't got time for that.
I know. I was like looking forever and you're supposed to try and find out if it's sensitive or resistant to these things and if that's going to make a circular or linear.
Hmm.
And I couldn't figure it out, so I just guessed. But okay, well.
Well, I'm glad we figured that out because I didn't know that. So
No, yeah, that's really. I'm gonna have to go fix some problems now in my homework I did.
yeah. That's good that you started on your homework though already. Let's do it.
No, because I have like work tomorrow, a test tomorrow, I have to write a talk tomorrow, and so
Dang.
I was like, I better get started today.
Where do you work?
At a clothing boutique,
Hmm.
so it's really fun.
One in Rexburg?
Oh no, I live up in Coeur d'Alene, Idaho right now.
Oh yeah, that's right.
Yeah.
Very
We
cool.
went up there a couple of weeks ago to one of the biking trails up there.
Oh no way. That's so cool.
Yeah, it was a lot of fun.
Should have
Long
came
drive,
and
but
said
it was-
hi.
Yeah, Jackson.
For jerk.
No, you guys would love Coeur d'Alene. I mean, I'm sure Jackson you do, but it's beautiful up here.
How far is it from Rexburg?
Oh yeah.
It's about 6 hours. I mean, if you drive fast, it's probably more like 6 to 7 hours.
7. All right.
But it's not. It's so beautiful. Like Rexburg. Like, are you from Idaho, Kevin, or where are you from?
I'm from Indiana.
Like Rexburg is so ugly. So ugly. Like Idaho is not like that. It is so green and so many mountains and so many trees and lakes. Like when I went to Rexburg, like I grew up in Idaho, and when I went to Rexburg, I was like, this is not Idaho. Like it's so
It's
ugly.
ugly.
Yeah. I'm like, why am I in a desert right now?
Yeah.
But so head up north and you'll love it. But okay, well, Jackson, are you gonna submit the link for this?
Yes, I will.
Thank you.
Thanks, Jackson.
Well, good luck on the test, you guys.
You too.
We'll see you next week.
All right, bye.
What time do you guys want to meet next week?
What works for you?
I mean, usually any time like after 4 on Friday would be good until maybe like I think 6:30 or 7 is like the latest, but I don't want to make you guys like miss work or anything.
I don't get off work until about 4:30, so I can be here around 5.
Yeah, I actually don't work this. I don't work this Friday, so I'm free whenever you guys are. So whatever works for you two, just let me know.
We could do 5:30 again. That way you're not rushed getting home if you want.
Okay.
Yeah, that sounds good. So
Okay.
5:30 Friday.
Cool.
Awesome.
Sounds good. All right. Thanks, guys.
See you then. Bye.
All right, bye.